All right, let's talk about how to name and write ionic compounds. So there's two learning targets here. The first one is use knowledge of ion charges to determine the ratio of ions within a compound and correctly write the formula for that ionic compound. And there's name ionic compounds and explain how to use Roman numerals when naming compounds with transition metals. Okay. When you're going to name something, like let's just say you have NaCl. We'll just stick with one you know. Check to see whether the metal is a transition metal first. And that's because we're going to need some special steps for that. And so Na is right here. It is not in the transition metals, which are right here. So we're good. Second step is name both ions, cation first. Oh, I skipped something. Check whether or not there's a polyatomic ion too. There's not. Okay, so name these. So we would say sodium, and then this is chlorine. If the second part is monatomic, it's just a single atom, then we change the ending to "ide." So instead of sodium chlorine, this is sodium chloride. If there is a polyatomic ion involved, never change the name. They have a special name for a reason. Only use Roman numerals to specify the charge of cation for transition metals. The most common exceptions is you'll see Roman numerals for lead and tin, which are not transition metals, and you won't see them for silver or zinc, which are transition metals, but always have a +1 and a +2 charge. Okay, so there are some exceptions, but here are the different possibilities. So transition metals are tricky because, for example, Fe, it can sometimes be a +2 and it can sometimes be a +3. And look how crazy Mn is. It can sometimes be +2, sometimes +3, sometimes +4, sometimes +6, sometimes +7. So you have to specify which it is, and we'll kind of see some examples of that. Okay, so let's try naming CaF2. That would be calcium fluorine, but we would change the ending to "ide since it's monatomic. So that would be calcium fluoride. The next one, Cu, is a transition metal. So we have to specify the charge. We know that it's bonded to 2 chlorines, and we know chlorine is always, always, always a -1. So if this is a -1 and there's 2 of them, what is canceling out a -2 charge? This copper must have a +2 charge. So we would write copper Roman numeral 2, which stands for +2 chloride. We still change the ending to IDE. But for the next one, CuCl, this one is just 1 chlorine. So what charge cancels out a -1? It would be a +1. So this would be copper Roman numeral 1 chloride. You can see why it's necessary, because if we just said copper chloride, how would we know if it was this compound or this one? And they are drastically different. Different colors, different properties, different melting points. So yeah, you definitely want to know. Number 4, Ca, and then if you've been studying your polyatomic ions, you would recognize SO4 as one of the 6 that has a special name. SO4 is sulfate. So we would just name this calcium sulfate. We don't change the ending. Okay, so let's do some. MgBr2. By the way, you might want to pause the video and try to do these yourself, and then come back and see if you got them right. So this one would be magnesium, and instead of bromine, it would be bromide. Next one would be barium, and instead of phosphorus, we would change it to phosphide. And the next one, calcium. instead of sulfur, sulfide. And then we've got one with a transition metal. So we can look up, we can see that Au is one of the transition metals, and it's with 3 chlorines. Chlorine always has a -1 charge. So if it's with 3 -1s, what cancels out a -3? A +3. So this must be gold, Roman numeral 3 chloride. And this bottom one, AlPO4. PO4 is one of the special 6 polyatomic ions named phosphate. So we would call this one aluminum phosphate. Okay, so now that we've got naming down, let's do the opposite. What if we need to write an ionic compound? So what if I said, okay, I want you to write out calcium hydroxide. That's one of the polyatomic ions. First step would be to write the symbol or formula of a polyatomic ion for each ion and write its charge above each. The cation always goes first. If the charges add up to 0, you're done. Mine do not, +2 and -1. If they don't, you play the crisscross game. So what that means is you cross the numbers, not the charges, down to be with the other element. So here we would have Ca1, parentheses, OH, parentheses, 2. So calcium hydroxide is CaOH2. You need parentheses because can you imagine if we didn't put parentheses here? We would have 1 oxygen and 2 hydrogens. And that's not right because what it really is a calcium with 2 OHs. So 2 O's and 2 H's. So that's why you need parentheses. Sometimes elements can have more than one possible charge, the transition metals, and the formula will tell you. All right, so let's look at a couple examples here. Aluminum oxide. Aluminum's got a +3 charge. To find that, you look on the periodic table and you look at the charge above it. Oxygen's right here, you look at the charge above it. So Al +3, O is -2, crisscross just the numbers, and we get Al2O3. Magnesium nitrate. Magnesium's a +1. Nitrate is one of the 6 polyatomic ions. It's got a -1. So when we crisscross, we need parentheses around the NO3. Otherwise, it would look like MgNO32, which is not right. So you definitely need parentheses. Iron Roman numeral 2 chloride, that means a +2 charge. So when you crisscross, you get FeCl2 versus iron 3 chloride, you would get FeCl3. All right, you try. Sodium, if you look it up, has a +1, and oxygen has a -2. So when we crisscross these, we get Na2O. We don't need to write the 1 because we're writing the O. Magnesium's a +2, chloride's a -1. So when we crisscross, we get MgCl2. Lithium is a +1, nitride is a -3. So when we crisscross, we get Li3N. Iron is Fe, and it tells us right here it's a +2 charge. Sulfur is a -2 charge, always. So we just slap these together and we get Fes. And last one, ammonium is one of the polyatomic ions. Phosphide, not phosphate, would be just a P, a monatomic ion. Parentheses for our crisscross, this will come out to be NH4 3P. There you go. More practice to come.